Hello students, let us continue to study the chapter Statistics. We shall continue solving the exercise 14.2. So in the last video we had learned two problems. So today let us continue solving the problems. This is the third problem. The relative humidity in percent of a certain city for a month of 30 days was given as follows. So this is the data which we are given. We are told to construct a group frequency distribution table with classes 84 to 86, 86 to 88. So now here if you see the class intervals, we have to start from 84 and we will see where we have to stop it at 99.2. So the last one we have to take will be 100 because if we see here the class size is 2 because we know 86 minus 84 will be 2 and here also 88 minus 86 is 2. So the last interval will be of 98 and 100 so that we can get 99 in the middle. Then which month or season do you think this data is about? So once we have the chart with frequency graph, we will be able, the table, we will be able to tell that and what is the range of this data. So let us start solving. So here we are told to construct the table and we have the data. So let us begin drawing the frequency distribution table. So for that, I will have the relative humidity which is given in percent. So I know I have to start from 84 to 86 as they have mentioned, then 86 to 88, 88 to 90, 90 to 92, 92 to 94, 94 to 96, 96 to 98, 98 to 100. So let us begin. So first we will search the frequency of the humidity which ranges from 84 to 86. So here we need not consider 86.5. We have to consider only up to 85. So this will not be there. Then in second row also nothing is there. Third row we have 1. So we have the frequency as 1. Then even 86 also we had only 1. Yeah, so I'll just mark here also as 1. Then 88 to 90. So if I check here, there is 1. And the other one is here. So there are 2. Then 92, 92. Again we go check 90.3 is there. Then we'll consider this. 90.2 is there here again. We'll write 2. Then 92 to 94. It will be we have 1. Then 2, 3, 4, 5, 6, 7. So we have frequency of 7. Then we have 94 to 96. 94 here. This is mark 1. 2, 3, 4, 5, 6, 6, 7. From 94 to 96, we have 94 to 96, we have about we have 6. Then 96 to 98. If you continue to do this way only, we get about 7. And if we do 98 to 100, we find that there are 4. So now if we add all this, we get the sum as 30. So now if you see the frequency, this is what it is. And if we see the range over here, it is all high because it is starting itself in from 84 itself. So usually we have a high humidity during the rainy season. So we can conclude that the data appears to be taken in the rainy season because the relative humidity is high because the values are starting from 84. Now the third question which was given, what is the range of this data? Now we know that range is the highest value minus the lowest value. So we have the table. Know the lowest value has to be something around 84 and the highest value about 100. So we had seen the highest value was 99.2 and the lowest value was 84.9. So on subtracting this, you get 14.3 as the range. With the next problem, the fourth problem from exercise 14.2, the heights of 50 students is measured to the nearest centimeter and it is given. Now we need to represent the data above by a grouped frequency distribution table, and here they have told us to take the class intervals of 160 to 165. But if we see here, we have given values of 154 and 150 also. So we will begin with 150 because that is the lowest number. And the highest will be 172. So the class size has to be 5. So the final value has to be 175 because we are increasing with 5. Then what can you conclude about their heights from this table? So we will only come to know about the heights once we draw the table. So this was the question. So let us draw the table. So this is the frequency distribution table where we've taken heights in centimeters and the frequency. So we have made different class intervals starting from 150 because we know 150 is the lowest value, and up to 175 because we have already seen that 172 is the highest value. So now we will start seeing the frequency. So 150 to 155, all those which are coming in that range. So I know 150 comes. So 1, 2, 1, 2, then it will be 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the frequency is 12. Then I go 155 to 160. So I need to consider up to 159. So 155. So I search for 155 in this. So here we have, so this 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this way, if you'll keep on doing, you will find that the frequency of the heights between 160 to 165 will be 14, and the heights 165 to 170 will be 10, and the heights of students between 170 to 175 will be 5. So on adding all this, we will get a total of 50. Now, what can you conclude about the heights from the table? So we see the heights of this table, we can see that the frequency range we see over here is more as compared to here. So we can conclude that we add this, this will be 15, and here if we add so we can conclude that about more than 50%. So this is only 15. So this will be more than about 50% students are shorter than 155, because here the upper limit is 165. This is the fifth problem. Here, a study was conducted to find out the concentration of sulfur dioxide in the air in parts per million, that is ppm, of a certain city. The data obtained for 30 days is as follows. So the data is given. We are asked to make a group frequency distribution table for this data with class interval 0. From 0 to 0.04, from 0.04 to 0.08, and so on. And how many days was the concentration of sulfur dioxide more than 0.11 parts per million. So what we are supposed to do is, we will draw the table. So we need to see which will be the highest value. Highest value here, if we see, is 0.22. We see the class size, it is of a difference of 0.04. So it is at a difference of 0.04. This is the data which we are given, and we'll draw the chart, and we will see now the concentration ranges in 0 to 0.4. So it's 1, 2, 3, 4, 5, 6. So it is We need not consider 0.04 because it is the upper limit over here. So it will be 4. Then when we consider 0.04 to 0.08, we did not consider 0.08. So it will be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now we have to consider 0.08 to 0.12. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Again we have 9. Now 0.012 to 0.16. We have this is also bigger, 1, 6. So I can't consider 1, 6 over here. 1, 2, I can say 1 and 2. So there are only two numbers. Then 0.016 to 0.20. So I have only 1 and 2. 2, then here also I have 1, 8. 3 and 4. So here it will be 4. And what am I left with? I have only this one and this one. So that will be 2. So when I add all this, I get a total of 30. Now, if we see this table, in second question is, for how many days was the concentration of sulfur dioxide more than 0.11 parts per million? So we see it that the concentration of sulfur dioxide more than 0.11 for 8 days. So these were the three problems which we solved in today's class. We shall learn to solve more problems in the next class. Thank you, students.